Welcome everyone. Today we are going to solve a numerical on the design of earthquake load. So let's move to other question. So here you can see the question according to the question given to us. The plan and elevation of 3-story RCC school is shown in the figure. Okay, that you can see, this is the figure. So the plan and elevation of 3-story building. So here we come to know that the building is of 3-story and it is of the building type is school. It is a RCC school. The intensity of dead load that is given to us, which is 12 kilonewton per meter square, which includes the dead load of columns, beams and wall as well. Live load on the building is 8 kilonewton per meter square. The building is situated in zone 4. So this is the seismic zone. As we know that the zones are divided into 4 categories. So this is the 4th zone in which the building is lying. The type of soil that is used here is medium soil, and it is proposed to design the building with a special movement resisting frame that is termed as SMRF. Okay, so what does this mean? We will look further in our question. So now what we need to find, we need to find the seismic force and the shear at each floor level using static coefficient method. So the main things which we need to keep in mind, that we are using this, we are going to find the seismic force and shear at each floor level using static coefficient method. So we are going to use static coefficient method. Now from this figure you can see that this is the plan and this is the elevation. Now so from the plan we came to know that the lateral width from the plan we came to know that the lateral width of this building is 5 and 5, that is total 10. So this is the lateral width, that is 10 meter. And talking about the longitudinal width given here is 4 and 4, that is 8 meter. So the lateral width is 10 meter and the longitudinal width is 8 meter. So I need to find the area, the plan area. From here you can see that I'm going to find the plan area. Actually it is going to help us in our further question in ahead. We need to find the plan area, so we are doing this right now. So the plan area, from here you can see that this width and this length I'm going to multiply. So area would be 10 meter by 8 meter. So our plan area would be 80 meter square. So this is the plan area. Now talking about the height of building, the height of building we can find that we know that from this figure that height of each story is 3 meter. It means that there are 3 stories, so we will multiply the number of stories by height of each story, that is going to give us 9 meter. Now as per the question that I have shown you before, from there uh, we need to extract some information. So we are going to solve this question step by step. So our very first step would be our very first step is step number 1, which says that we need to find the lumped mass to various floor levels. So here you can see, according to the data given to us in this question, we know that this building consists of 3 stories. So from that we need to find the total mass, total load on this building at various floor levels. So first we are going to calculate the dead load. So as per the question given to us, in this question the dead load is given at every floor. At each floor the dead load is 12 kilonewton per meter square. This is the intensity of dead load which is given to us for each floor level. Now the weight of typical floor, if we are going to talk about a particular floor, so how we gonna find that? As I have already find in the question that this is the plan area. Okay, this is the plan area which I have already found by multiplying longitudinal width and lateral width, that is 8 multiplied by 10, that is going to give us 80 meter square. So this is the plan area, this this is the plan area, and when plan area multiply by the load intensity, the dead load intensity on a particular floor, it is going to give us 960 kilonewton. So this is the total load on this particular floor. So now talking about the unit conversion, so from here you can see that the unit of plan area would be meter square, and when multiplied by the intensity of load, that is kilonewton per meter square. So here you can see that from meter square to meter square it's going to be cancelled out. So now the unit of this load will be totally in kilonewton. Now talking about the weight of roof, I will tell you that why I am calculating the weight of roof separately. Now one thing we need to keep in mind, that we have to calculate the weight of floor and weight of roof separately. Now talking about the weight of roof, so from here you can see that I am again going to multiply the plan area by the intensity of dead load, that is going to give me the value that is 960 kilonewton. Now talking about the live load, so it is given to us that is 8 kilonewton per meter square. So for the live load on roof, so the imposed load on roof is 0 kilonewton. Okay, this I am going to show you in the code that why we do not consider a live load on the roof. But the second point is live load on each floor. This is the talk of roof, and now we are calculating the live load on each floor. So generally here two condition arises for the calculation of live load on each floor. So the first condition is that when live load is less than equal to 3 kilonewton per meter square, when the intensity of live load is less than equal to 3 kilonewton per meter square, so we will consider 25% of the live load. So now moving to the second condition, that is when live load is greater than 3 kilonewton per meter square, what we are going to do, we are going to consider the 50% of the live load. As per our question, the live load is 8 kilonewton per meter square, which is obviously greater than 3 kilonewton per meter square. So according to this condition, we came to know that we are going to use the second one condition, that is the 50% of live load we are going to consider. So as per the load given in our question, here you can see that 8 kilonewton per meter square is greater than 3 kilonewton per meter square. So we are going to consider this condition for the finding of live load. So 50% of 8 kilonewton per meter square would be 4 kilonewton per meter square. Now after calculating the live load, so the total load on each floor will be, okay, so now we need to calculate the total load on each floor, that will be 320 kilonewton. So I'm going to explain you that how we calculated the total live load on each floor. Okay, so this is the plan area which I have already told you in the beginning, that how we just find this by multiplying the lateral width by the longitudinal width, that is 80 meter square, and this is the intensity of dead load. This is the intensity of dead load on each floor. So it will after multiplying these two values, it is going to give us the 320 kilonewton. Now after calculating the dead load on floor and the dead load on roof and live load on floor and live load on roof, we are going to move to find our lumped or total mass of roof. So what is lumped mass? As I have already told you that for the finding of earthquake load, we need to find the lump or total mass of roof. So lumped mass is the combination of dead load plus live load. This is the total load which we are just going to consider on our roof. So as I told you earlier that we do not consider the live load on the roof, we only consider the dead load. So the dead load we have already calculated, that is 960 kilonewton, and the live load we are considering as 0. So our lumped mass would be 960 kilonewton for the roof. After calculating the lumped mass of roof, we are going to calculate the lumped mass of each floor. So again, the lumped mass of each floor would be the combination or the sum of dead load and live load. So dead load we have calculated, that is 960 kilonewton, and live load on each floor that have already calculated by taking the 50% of live load, that would be 320 kilonewton. So after summing the dead load and live load of each floor, we are going to get the value 1280 kilonewton. So we have already calculated that. Now this is the total mass on the roof, that is 960 kilonewton, and this is the second one is the total dead load. So we know that this is for the roof, and this value is for the calculation of load on the floor. So we know that this is a 3-story building, so this one would be generally the roof. So this is the load on roof, and we know that we have 2 stories left. So after multiplying 1280, that is the dead load value on the floor. So we have 2 floors generally. So after multiplying the load on each floor by the number of floor, it will and adding it with the load on the roof, it is going to give us the value 3520 kilonewton. That is the total seismic weight of this building. Now we need to calculate the fundamental natural period, that is denoted by TA, and the value of TA is generally calculated from this formula, that is 0.09 multiplied by h and whole divided by under root d, that is small d. Now for the calculation of the approximate fundamental natural period of vibration, that is TA, we are going to use this formula, that is 0.09 divided by under root D. Here D means the base dimension of the building at plinth level in meter along the considered direction of the lateral force. So as per the plan which I have already showed you in the question, so this is the plan, and according to this plan, that this is the longitudinal direction and this is the lateral direction, and I am considering the force along the lateral direction. So this is the dimension which we are going to take. So D would be 8 meter. Now one thing I'm just going to clear here is that in the formula that is given in the code, that h was not given, so h is need to be considered. So h, how we going to find the total height, that I have already taught you, that how we can calculate the total height of building, and the total height of building would be 9 meter. So we are considering the total height of building, that is 9 meter, and the D dimension we are considering as 8 meter. So after that we are going to solve, and this the value would for the TA, that is the approximate fundamental natural period of vibration, that would give us the value, that is 0.286 seconds. Now in the step 3 we need to calculate the design seismic base shear, that we are going to denote it by VB. So the VB formula would be AH into W. W would be the total seismic weight that we have calculated in the step number first, and AH can be calculated from this formula. Now I'm going to show you the code which IS has recommended. Now from there we can find that what actually these all parameter means. Purpose of determining seismic force, the country is classified into 4 seismic zones, as we know that is a zone 2, zone 3, zone 4, and the last one is 5th zone. So according to a question, that we need to calculate the value of AH by using this formula, that is Z multiply by I multiply by R. So what does it mean? That Z here means zone factor. Zone factor is calculated from the table number 2, which I will show you. So this is the zone factor. So from here you can see that our building, that is the RCC school building, which is given in our question, that it is lying in the 4th zone. So for 4th, the seismic intensity will be severe, and the value of Z would be 0.24. The next value that we need to calculate is I. So I we can find from the table number 6. This is the table number 6, from where we can find the value of importance factor, that is 1. So the important services and community building such as hospitals, schools, monumental services, emergency buildings like telephone exchange. So for these all kind of buildings we need to consider the importance factor value, that is 1.5, and for all other buildings other than these type of buildings we need to put the value of I, that is 1. The next thing that we need to find is the value of SA by G. So one thing I would like to just tell you, that this SA by G would be always kept together. So these will always be considered as the ratio value, that is SA ratio G. So as I told you that the value of SA by G depends on the value of soil and the value of TA. So as per the data given to us, the type of soil is medium soil. So after calculating all the important parameters, the last parameter that is left, that is R. So to find R, and for the value of response reduction factor for spatial moment resisting frame, we generally consider as 5. So this value you can find in the table number 7 as per the clause 6.4.2. So after obtaining all the value of Z, I, S, A by G, R, we are going to put all these in this formula, and the final value, that is for AH, would be 0.09. Now we have find the value of AH, that is 0.09, and we already have find the value of seismic load, that is W. So after multiplying both these, after calculating our three steps, the fourth step is vertical distribution of base shear. So we know that the vertical distribution, why we are calling it vertical distribution, as because the total load that we have calculated, the base shear is distributed among differently among all the floors. And for the calculation of this, we have a formula, that is VB into WI square whole divided. So from here you can see that the VB, that is the base shear, design base shear. Okay, so QI value represent the design lateral floor at floor I. It means whatever I here can be replaced by the number of floor at which we are going to calculate the value of QI. So Wi is the seismic weight of floor again, and Hi is the height of floor measured from the base, and N is the number of story. As we know that our base shear that we have already calculated is 288 kilonewton. So after preparing a table, here Wi is the seismic weight of floor, Hi is the height of floor measured from the base. So one thing you have to remember, that if suppose this is the building and these are the stories, so we have to consider all the values of height from this base. So we have to calculate, we have to consider the height from the base for each particular floor. After finding the value of Wi and Hi, so we are going to square the Hi value for particular floor, and after that we are going to multiply it by the Wi. So this is the multiplication which is going to take place, and after that we will get the different value for different level of floors. After that we are going to sum up all these values of WIHI square, that is going to give us 135360. After that we are going to divide it, the individual WIHI square value by the summation of WIHI square. So after that we will get these values for different floor levels, and at last we are going to find the distribution of design force for different level of floors. So this is the formula which we are just going to apply now for different floors. So after applying this formula, these are the value which are going to be obtained, and after that we are going to submit we are going to add all the values of qi. We are going to use the formula like cumulative frequency. So we are going to add this value by this, and again this total which we are going to get here, we are going to add it with the uh, floor 1, so it will give us this value. So this is the way to find the shear force for different level of floor. This is the last column that you can see. It consists of shear force of every floor level. So as per the data which we have calculated or extracted by using different formulas, after that we are going to build this diagram. This is the lateral load diagram, and this is the shear force diagram. So for the different value of shear force, there would be the variation in these graphs. So I hope this video was helpful for you, and it will help you in your examination, for your university examination. So thank you.